Welcome to this chapter on transmission diagnosis. My name is Steve Garrett. I'll be your host for today. We're going to discuss how to diagnose the on-off solenoid designs used in many of the earlier General Motors vehicles. With that said, let's take a look at a typical on-off solenoid that you'd see in a 4L60E, 4L8E, 4T8E, 4T65E application, as well as a few others. The solenoid itself is basically nothing more than an electromagnet that in turn is controlled electronically to control the magnetic field, which in turn then controls the check ball built within inside of the solenoid assembly itself. So as the solenoid is energized, the check ball, of course, is either going to be unseated or seated, depending if it's a normally open or normally closed solenoid, which then either allows the oil to exhaust or oil pressure to build up at the end of the solenoid itself, which then becomes signal fluid to control the operation of a shift valve. So when we look at the operation of a typical on-off solenoid, we're going to have power being sent to the solenoid, and a controller is going to typically control on a GM vehicle the ground side of the solenoid. Be a little bit different, obviously, when we deal with some of the foreign type vehicles. When we look at the controls that you're going to have built into this application, your controller, which is going to be a PCM, a TCM, or a vehicle control module, VCM, on a GM is going to be controlling the ground side of the solenoid itself. So again, we're going to have power fed typically from your ignition switch, which of course has been a major problem in most GMs, which is then going to be fed through the solenoid to the TCM, PCM, or VCM, and the VCM then simply controls the ground side of the circuit itself. When the ground is turned in the off position, if you had a meter plugged into that particular ground source itself at the TCM, you'd see that you got battery voltage available at that particular pin. When you ground that pin through the VCM, TCM, or application itself, you're going to see that voltage will be pulled low, typically less than about a half a volt. So what we're talking about here is that the voltage is going to rise and fall depending on whether the solenoid driver circuit is opened or obviously closed to ground. Now, what I'm referring to as solenoid driver circuits are actually what we call drivers within the solenoid circuit board itself. They're basically a IC type chip, which is in turn used to control the ground source for the solenoid. That ground source itself, again, is going to be controlling those different shift solenoids. Now, we're not talking about PWM solenoids. We're talking about on-off style solenoids like you would see at the 4L60E. As I talked about earlier, if you had a meter plumbed into that particular pin at that controller, you would see you'd have battery voltage available when the ground is turned off, and you'd have around a half a volt when the ground is turned on. In other words, the voltage drop is occurring across the solenoid. So what we're basically going to talk about now is how the controller has a built-in voltmeter built into it for your diagnostic process. We call that a feedback circuit. So built into most of the controller chips, basically parallel to the ground driver itself, is going to be a feedback line. In other words, a sense line, so we can actually sense what's happening to the voltage at that ground source. So that makes it where we don't have to hook up a meter to see what's happening electronically at the controller itself. So by simply monitoring the feedback line, it's like having a built-in voltmeter. You don't have to take the time to actually hook the voltmeter up. Your scan tool will simply help you with diagnosing it based on what you see on the scan tool itself. When you look at any of the 4-speed GM application transmissions, you're going to typically run into a situation where the solenoid is going to be turned on for one position and off, obviously, for another position. The sequencing of those solenoids determines which gear range you're going to get. So if you look at what we're basically going to call the solenoid truth table itself, as you can see here in first gear on a 4L60E, both solenoids are on. They simply turn solenoid A, or the 1-2 solenoid, off to get to second gear. They turn the solenoid B, or the 2-3 solenoid, off to get to third gear, and they of course turn the 1-2 solenoid back on to get to fourth gear. So if you look at the sequencing on any of these transmissions, again 4L60E is our example, you're going to see both solenoids on in first, both solenoids off in third. So we're simply reversing the position of the solenoids themselves. When we're talking ons and offs, we're talking about electrical commands to these solenoids. So by understanding this simple process, you can in turn help yourself diagnosing the vehicle. That means that not only can you obviously use this truth table for diagnosis electrically, but you can also use it for mechanical diagnosis. Here's what we mean by that. If you have a mechanical failure of the solenoid, and again, we're looking at a 1-2 type solenoid here, or a solenoid A in other words. If the solenoid was caught in the off position hydraulically, so as you're seeing on the top of the chart, you would default into second or third gear. If the solenoid is caught into the on position hydraulically, then you're going to end up with first and fourth gear. So what can we conclude from that? We can conclude basically that each solenoid is in charge of 2 gear ranges. So if you lose a solenoid mechanically, any 4L60E, 4T80E, 4L80E, 4L30E, 4T65E, 4T60E transmission, you're always going to have 2 gears as your default. So which 2 gears depends on which position the solenoid physically fails in. So if you looked at the 2-3 solenoid fault in the chart, as you can see, you're going to end up with it stuck in the off position, ending up with 4th gear and 3rd gear as your defaults. If it's stuck in the on position, it's going to be 1st gear and 2nd gear. So again, it depends on which position the solenoid is physically caught into mechanically for what kind of default action you're going to get. When you look at a 4L30E, it's a little bit different player. 5L40Es are basically the same. As you can see, we're going to end up with 2 gears, but the gear positions are going to be a little bit different depending, again, which solenoid you actually had fail. So this truth chart basically tells you what gears you're going to result in getting if, in fact, you in turn have either the solenoid mechanically stuck off or mechanically stuck on. Now, in most instances, a mechanical failure of the solenoid will result, obviously, in a ratio error code. But if you have an electrical failure, you may get a code, you may not, depending on what the level of software is in your vehicle. When we look at electrical failures, there's only 4 types of electrical failures you can have. We're going to divide those electrical failures into 2 different failure categories: low voltage failures and high voltage failures. So that will help cut our diagnostic time tremendously. So when you're talking about the different types of failures, we're talking about obviously a failure where you have an open circuit or an open solenoid, a short to ground in the circuit, a short to B+ in the circuit, or a shorted solenoid. So those top 2 that we're talking about are developed obviously if in fact we have a low voltage failure. The bottom 2 we're talking about are going to be there if we have a high voltage failure. Now there is voltage when we're not supposed to have voltage. So we can divide our diagnostic into those 2 routines and cut our diagnostic time by 50% if we simply understand that one principle. Now, when you talk about diagnosing one of these transmissions electronically, your scan tool is your best friend. Your scan tool and your digital multimeter. Those are 2 things you need to own. Your scan tool is going to give you what's known as feedback voltage on a lot of the different design solenoid circuits. So some of the earliest stuff didn't have this, but all the later model stuff did. So we're going to have different designs of this feedback voltage depending on the design of the driver chip that's in the controller itself. We're going to call one design driver a QDM. We're going to call another design driver an ODM. QDM stands for quad driver module. ODM stands for output driver module. Basically what it boils down to from your position itself is it's going to look different on the scan tool. It works basically the same way in the controller, but you're going to see different results obviously on your scan tool. So on the QDM feedback lines, you're going to have what we have known as matching feedback lines, where they're going to actually be a mirror of what happens with the command status on the circuit itself. You can also have an ODM feedback, and it's going to appear different depending on what year and software is in this vehicle. Some of them will display faults as an OK or a fault being present. Other will actually display, just like we just talked about, a feedback line value that you can actually look at. So when we're talking about the driver circuits themselves, we're actually talking about the chip that's mounted internal to the TCM itself that's basically used to control the ground source for the solenoid. So as you can see in this schematic, we got 12 volts coming from the solenoid, typically from an ignition switch, goes through the solenoid to that driver circuit. When that driver circuit is open from ground, the feedback voltage will be high. When in turn the driver circuit gets grounded, then the feedback voltage will actually be low. You'll actually get that voltage displayed right on your scan tool to help you diagnostically, so you don't even need to hook a meter to it if you've got feedback status on your scanner. Now, the first design we're going to look at is a QDM design. This quad driver module design itself was the first attempt, obviously, to make it a feedback circuit so that you could use it diagnostically. A lot of vehicles have this. So we're showing you the command status for both the 1-2 and the 2-3 solenoid in this picture. What we're basically telling you here is when you command the solenoid on, the feedback line has to match unless there's a problem with that particular solenoid electrical circuit. When you command the solenoid off, the feedback status again has to match what the command status is unless there's an electrical fault with that circuit. So in this instance here, you're seeing the 1-2 solenoid being commanded on, the feedback line also matching, saying on. You're seeing the 2-3 solenoid being commanded off, and you're of course seeing the feedback voltage value itself also indicating off. What we're basically telling you here is this circuit itself is functioning correctly. So if the feedback line and the command status are the same, that means basically there is no problem with this system. When we develop problems, it's when these feedback lines and the command statuses fail to match. So in this instance here, you're looking at a 1-2 solenoid being commanded on and the feedback line indicating that it is off. So that indicates that we have a problem. So anytime you in turn have a situation where the feedback line and the command status fail to match, that's indicating to you an electrical failure with this. So when the line is of course off, that means you're seeing high voltage, but the solenoid command says you should see low voltage. So that means we obviously have a short to voltage somewhere in that circuit, obviously, or a shorted solenoid or a bad controller that's causing that first scenario. The bottom scenario you're seeing is the 1-2 solenoid being commanded in the off status and the feedback line indicating on. So what we're looking at here is the 1-2 solenoid is being turned off, which basically means the voltage should be high, but the feedback line says that the voltage is low. So that indicates to us, again, that we have something taking away the voltage. That indicates that we're either going to have a short to ground in the ground side of the solenoid circuit or an open someplace in the circuit itself. And of course, just like the other failure, you can of course have a bad controller. So you're going to then use your multimeter to diagnose where that problem is at and separate obviously a harness/solenoid issue from a controller issue. When you look at the feedback lines on some of the ODM type circuits, it gets a little bit easier. We got a type 1 and a type 2 design that were used in these controllers. So as you notice here, we got a solenoid command that basically for the 1-2 that's on, and the 1-2 feedback says OK. Same thing for the 2-3. The bottom picture you see says the solenoid command is on, but the feedback line indicates a fault. So again, just like we did before, when we're commanding the solenoid on, the voltage is supposed to be low. The feedback line says it's not low, which indicates obviously we got a shorted solenoid or a short to B plus in the ground side of that solenoid circuit, or of course a controller that's giving us problems. We go the step further. Now we got the solenoid being commanded off. So the 1-2 solenoid is in the commanded off position, which basically means the driver is open. In this instance, it indicates that we have a fault on that 1-2 feedback circuit. So again, with the solenoid turned off, the voltage should be high, but it says no, the voltage is low. So that built-in multimeter that's built into the circuit is telling you that circuit has a fault in it. That indicates, obviously, if the voltage is supposed to be high and it's low, something has to be taking the voltage away. That would mean we have an open solenoid, we got a short, obviously, to ground in the solenoid side, ground side of the circuit, or of course we have a fault within the PCM-TCM. So again, basically the same thing we just did before, but the look that you get on the scan tool is a little bit different. Now the type 2 of the ODM style drivers looks a little bit different also, but it made it again easier to do the diagnosis. So you got the command again for the 1-2 solenoid, and then we're showing you 1-2 solenoid shorted to ground or open, 1-2 solenoid shorted to voltage or shorted. Those should always stay no. Anytime one of those changes to a yes, that indicates that is the fault that you're looking at. So on the bottom display that you see there, as you can see, it says 1-2 solenoid shorted to voltage or shorted, that means we have a high voltage failure in that circuit itself. So again, we have a possibility of 3 different things that you have to look at. You're going to have to use your digital multimeter to separate each of those apart. 4T60Es are a little bit different when it comes to the design of the feedback circuits. You can have bunches of different combinations of feedback lines and how they actually appear. So you're going to have to take your time when it comes to a 4T60 or 65E. What gets confusing about the 4T60Es is they've got multiple different quad driver modules, and they put multiple different components on those drivers. That's what gets confusing about it. Some of these have up to 8 different drivers. So you have to get a wiring schematic out. You have to locate who is on which driver for your particular PCM application so that you know, obviously, when it indicates there's a fault, who's actually at fault. So if we looked at that quad driver number 3, for example, it could be a cooling fan, an AC clutch, shift solenoid A, shift solenoid B, or TCC solenoid. So again, your diagnostics get a little bit more in depth because you're going to have to separate those from each other. So it's not as clear as what we just went through before. North Star applications, 4T80Es. You got a couple different designs on the North Stars that you need to be aware of. One of them has built-in onboard diagnostics. The other, of course, like the Aurora, did not have built-in diagnostics, so you'd have to use a scan tool on it. On those with built-in diagnostics, you of course enter the onboard diagnostics by pressing the off and warmer button on the climate control panel, and then of course using your fan controls to go up or down based on your question mark for what they want you to basically do. It's going to say, do you want a PCM data? Do you want codes? You can get a lot of information out of here. Well, in the data portion of it, you're going to look at some PIDs, and those PIDs are going to be PID 16 and PID 17. Those are going to give you your quad driver modules. Quad driver A, B, C, and D are on PID 16, and PID 17 is going to have quad driver E, F, G, and H. What we're looking for, guys, is there's going to be either a 1 or a 0 displayed next to each of those PIDs. So as it says A, it's going to either have a 1 or 0 next to it. B, same thing. A 1, of course, is bad in this instance, indicates there's a fault. A 0 indicates that there is no fault. So as the solenoid cycles between on and off, it should stay 0. So if the solenoid course cycles to the on position, it indicates a 1, we have a fault. If the solenoid obviously is in the off position and it has a 1, there is a fault. So just like we did diagnostically before, we're going to diagnose it the same exact way, except for you're having 1s and 0s rather than good, bad, on, offs that you're basically diagnosing. When you look at the diagnostic process itself, it does get a little more complicated on some of them, because you're going to have to run it through the gears to be able to separate which solenoid is giving you troubles. So we're looking obviously at the different fault lines themselves. Depending on which gear will tell you which solenoid, of course, has the failure. So that's what we're highlighting obviously in the bottom of this text. Late model 4T80Es, and of course those also used in the Aurora, they don't do their diagnosis through the onboard diagnostics. They've changed over to the scan tool diagnostics. That was part of the OBD2 changeover. So in this instance, you're going to see again, we got solenoid driver number 1, solenoid driver number 2, a TCC driver, and a PWM driver for my TCC circuit. Those, of course, should indicate, just like we did with the output driver modules, either an OK, an open, or a short to ground, or an overcurrent condition. So they diagnose it right down to the exact thing that you're looking at as a failure. So if you're looking at solenoid driver number 1, output driver, which is number 2, which is output number 5, that's my 1-2 solenoid. Again, if it said you had a open or short, that basically means that you have a low voltage failure with this circuit. If you had an overcurrent, this displayed on your scan tool, that means you have a short to power in this circuit, and you'll have to address it as such. So as you can see, the bottom line with this is that scan tool is going to give you a tremendous amount of information if you understand how to use it. So take yourself a little bit of time, obviously go out and drive some of these vehicles and watch the feedback line status as compared to your command status. status. That's going to give you a very good idea of obviously if you have a problem with your vehicle or not and what that exact problem is. What we basically have done is we've cut the diagnostic time tremendously by giving you this source of information itself on your scan tool. So again, take yourself some time, learn this technology. It's going to help you a tremendous amount in the future. We hope you've enjoyed this presentation. We'll see you the next time.